Welcome to my tutorial about using R with direct access. So this tutorial is aimed at people who are using Delta DNA and who have direct access, who want a really flexible way of looking at their data, manipulating their data, plotting their data, and building models. But this tutorial will work for anyone. You don't have to be a Delta DNA user. It's really just a beginner's tutorial to R. And this tutorial is going to be a little bit different from other R tutorials you might see, because I'm going to focus a lot on the use of dplyr, which is an R library which makes manipulating data in R really easy. So if you're a complete beginner to R, you'll need to install R, and you'll also need to install RStudio, which is the IDE I'm using here. So just go to their websites. Right. Here's the R website. Just go to Downloads in CRAN and download the latest version. And here's RStudio's website. So you'll want to be probably running RStudio desktop, and you'll probably want the free edition. So RStudio is a really good IDE for R. I would really recommend it. But you don't need it. Okay, and once you've got R downloaded, and then you've got RStudio downloaded, I would also recommend making a project in RStudio. It's really easy. File, new project, and then you've got some options. So a project's really just a way of keeping all your files together in one place, and it makes moving your files around easier, and it makes loading in external data easier. Okay, I'm going to start by explaining how to load the data in from direct access. If you don't have direct access, there's going to be a CSV file of comparable data that you'll be able to download from our website, and you just load that in with data and read.csv. I'll type that out for you just now. So you want the data object to come from reading a CSV, and then whatever your CSV's name is. So I think we've called it currency. Okay, and that's not going to work because we don't have a file, but if you download the file, the currency data file, and you put it in the same folder as your R project and as your R script, then that will load the data into the object data. Okay, but if you do have direct access, it's worth going over how you get data from direct access. So one other little thing before I start. So there's basically two ways of running commands here. Your version of RStudio might look a little bit different. I've sort of rearranged the panels a little bit, but basically you can either type commands in here. So here's a command, I can run it. Or you can type commands in here. I'll type a command just to show you. And then you can run that by using Control-Enter or Control-R. And it will run over there. Okay, so let's get started. So the direct access data is kept in the database, so you'll need a library which helps you interact with that database. In R, it makes it really easy. So the library I'll be using is called R PostgreSQL, but you can have a look and use other libraries are available. If you've never used the library before, the first thing you need to do is use install packages to install the library. So I'm not going to run that because I have the library. But if you don't, every time you use the library, you need to load it into your session, just with the library. Okay. Right. And then you'll need to set up the driver, which should just be PostgreSQL, and you'll need to set up a connection. So you're going to need to put your own username and your own password, and the host will be for you as well, data.deltadna.net. So I'm going to be using Delta Crunch, but you can use your own games data if you want. Everyone should have access to Delta Crunch, so if you want to follow through the tutorial, then you should be able to use this. Right, let's run all that. Let's see what happens. Okay, so it's got a connection, and now we're going to use this query. So I've written the query in a separate text file. This is just a bit of SQL, so I'm sure quite a lot of you will have seen this before. If you haven't seen SQL, I'll talk you through it really quickly, but SQL is quite straightforward. It should be quite obvious what's going on. So the events live table has all your events in it. It's got lots and lots of columns. I think for Delta Crunch it's got about 60 something columns. But what we want is the user IDs. We want the time of each event. So for each event, you're going to have the ID of the user who made the event, the time they made it, their gender, their age group, and the amount they've spent. And we're only going to take these out of the table if they've actually spent something. So basically this query is giving us all the events which correspond to somebody spending some money. We're going to know the time it happened, we're going to know the age group and the gender, and we're going to know the user ID. Okay, so use the readLines function to take in the query. Right, so now we've got an object called query. We'll need to, I'll show you, query currently looks like this. So it's, you can see it's a list, it's split over several lines. We need to stick the query together, and we do that using this second function here. Now we're going to have a look at query. Okay. Doesn't look pretty, but it will work. And then we can just run the next command, which is dplyr, which will put our data into this file here. Okay, it's quite a bit of data, so it'll take a little minute. If none of this made sense to you because you've never seen R before, don't worry, I'm going to kind of talk through the basics of R a little slower in a minute, but you need to be able to get the data out of direct access, and I think a lot of those steps will make more sense once you know a bit more about R. Okay, so we've got the data, we've got it in a variable called data. Let's have a little look at data. Right, so that wasn't very helpful. You can tell there's something there, but there was so much of it and it all flew past our screen very quickly, and it just goes on for hours. So str, structure, it's a very useful R function. That will give you a bit more, tell you about the structure of the data. Okay, so it's telling us it's a data frame. It's got 14,000 observations and 5 variables. So a data frame is a bit like a table in SQL, or a spreadsheet in Excel for that matter. It's just a big table of data. And it's got rows and columns, and here the rows are these things. There are variables, user ID, time, gender, age, amount, spend, group, and the columns are observations, which is just each observation corresponds to one event. Okay, so we can also use the view function, the capital V. It's quite useful, and that will take up another tab, and we can look at this in more detail. It looks a bit like Excel, doesn't it? You can't edit anything here, but it's always nice to have a look, check everything looks right. Okay. Okay. So that was data frames. They are one of the most important data types in R, if not the most important data type. They're where all your information is stored. Data frames are made out of vectors. So they're basically a list of vectors. And you can access elements of the list by using this $sign here. You see that? So look at structured data. It says $sign. Let's look at spend amount. $sign spend amount. So to get to the spend amount variable, we just do that. And again, if you just run the command, you just dumps everything in the variable to the screen. It's not very useful. So instead, we can use the structure command again. Okay. So what this is saying is that it's a numeric vector. It goes from 1 to 14,000 and it tells you the first two values. Okay, so now we've got this far and we know what data frames are and we know what vectors are. You know, data frames are made out of vectors and you can access them by using the $sign. How do you work out what the mean amount of currency spent is? Easy, we just use the mean function. One of the reasons that R is so useful is because if you're doing data analysis, it's got a lot of stuff built into it. So I know other languages don't have inbuilt mean functions, but when you're analysing data, you want to do that a lot. So average amount spent is 524 cents. Yes, watch out for that the spend amount is in cents. What about the median amount? Median amount is 299 cents. Okay, interesting. So that was all base R. That's all your basic R as it comes out of the box. Now that's all I'm going to talk about for just now because we're going to move straight on to using dplyr. So again, like the PostgreSQL package that you use to get data in, you need to install dplyr if you don't already have it. But if you do have it, you just load it into the session. Okay. So one of the most useful features of dplyr is that you could convert data frames into tabular data frames. And tabular data frames are almost exactly the same as data frames, but we'll see in a minute. That's the function. This is the function to convert it to tabular data frame. Let's have a look at it. You print it to screen, it sort of gives you a more concise summary. Okay? Which is useful, so you don't have to keep using str. Right. So to understand dplyr, you need to understand the 5 verbs that get used. And if you've ever done SQL before, this should seem quite familiar to commands you use in SQL. You've got a data frame. There's 5 main things you can do to it. You can select only some of the columns. So here, this data frame's got all the columns, but if I run select on it, so also notice here we're doing select, and the first argument is the data frame we're doing it on, and the second argument is the columns. You can put as many columns as you want in there. Okay, so now it's only selected the time and the gender variable. Okay, straightforward. Filter. So select works on columns, filter works on rows. So this time we're going to taking in the data frame, and we are only looking at rows where the spend amount is greater than 999. Let's run that, see what happens. Okay, so the full data frame, we've got all the columns. We can't really see it because it can't fit on the screen, but hopefully we've only got the columns that are where the spend amount was greater than 999. Let's just rearrange that. There we go. Yep. Okay, and it's also telling us that, remember before we had 14,000 observations, so now we've only got 1,000 observations. Okay. So all of these take in a data frame as the first argument and return a data frame. Pop back to the end. Okay. Arrange. Arrange is a bit like order by in SQL. So you first argument, taking the data. Second argument, what you want to arrange by. We're going to arrange by time. Let's pull this out, have a look at it. Yep, and now the data frame, it's exactly the same data, but it's in a different order. So it's starting with the very first event, then the next one, then the next one. Okay. Okay, mutate is a very useful one. What that does is it makes new columns. So in this case, so you know how I was saying earlier how it's easy to get modelled up because spend amount is in cents, not in dollars like you might expect. So we're going to basically create a new column which is spend amount in dollars. and just dividing by 100. Okay? And we're going to call that column spend amount. And what that will do is it will overwrite this column here. So let's have a look what happens when we do that. Okay, so same size data set spend amount. It's now in dollars, not cents. Okay, the last verb is also very useful, but we're going to see the real power of its use in a minute once we learn about group bys. But basically, like the other verbs, takes in a data frame, returns a data frame, but it's summarizing many rows of the data set. So while mutate, the data frame you got back was the same size as the data frame you put in. Let's see what happens when we run summarize. Okay, you get back a much smaller data frame, because basically what it's doing is finding the mean. It's finding the mean of all the spend amount, and it's finding the median of all the spend amount. So that seems like a slightly more awkward way of doing what we did up here. But I assure you it can be very useful. Okay. Right, now so you've got your data in, and you have a few questions about the data. And you want to use dplyr to solve those questions. Let's have a think about how you do that. So the first question I have is spend amount different for different genders? Okay. And I'm also going to introduce you to group by. Okay. So the thing is here, when we were running these, we were just taking in the data frame and outputting it there, and it wasn't ever changing. So let's save the results of doing this here, of doing this mutate. Let's save it into something called data2, so then we can work with that in a minute. So data2, changing it to dollars. Have a quick look at data2. What's it look like? Data2. It's not giving it enough space, so I can't look at it. There we go. Okay, so now we've got a new variable which has got spend amount in dollars. We're going to run a group by on it. So you can probably read this yourself. Data3 is going to be data2 but grouped by gender. What happens when we run that? Let's have a look at data3. How is it going to look different? Okay, so have a look. It actually doesn't look different at all, does it? It's exactly the same data frame. Group by on its own doesn't actually do anything. You'll notice up here it just says source, and up here it says source and then groups, so it has done something. So data3 is different. And now, as I said, summarize gets very useful when you use group by. So remember before when we summarized and we did the mean and the median, just found the mean and median of everything. Since we're grouped by gender, let's see what happens. Okay, so instead of just doing it for all the variables, it's done it for each gender. So now we know what the mean is for females, the mean is for males, and the mean is for unknown gender. And I've also used this function here, which just counts the number of observations in each group. So we know a lot of females, about a tenth as many males, and a small amount of people are unknown. And also, so their mean and their medians look pretty similar. So it seemed like average spend isn't different across genders, but you have a lot more females than males. Okay, so I hope that seemed relatively straightforward. Mutate, group by, summarize. So it's a bit, I don't know about you, but it's a bit annoying how we had to keep calling things data2, data3, data4. And you can see if you're doing a more complicated analysis that would get, and you lose track of where you were and what each data had, and just doesn't look very clean. So we're going to learn about what I think one of the best features of dplyr is, which is pipes. So ignoring the data for a minute, let's look at a function in R called identical. So the thing to understand about pipes is pipes are used for dplyr, but that doesn't mean that pipes can only be used for dplyr. They can be used for like any function in R, but they are very useful in dplyr. So let's have a look at this identical function. All it does is checks if two arguments are identical. Are 4 and 4 identical? Yes, they are. Are 5 and 4 identical? No, they're not. Okay, so what piping does is, what I've written here is the same as what I've written. Sorry, what I've written here on this line is the same as what I've written on this line. Because the pipe takes this number here and puts it as the first argument into this function. Doesn't seem that useful just now. So the 4 is going as the first argument of identical, which will make identical and identical 4, 4. Let's run that, check it's the same. Yep. And 5, same thing here. The 5 is getting put into the first argument of identical. So 5 and 5 are identical. If I went and changed this to 4, it would be false, because that's just the same as this function here. Okay, so pipes. Take the argument on the left hand side, put it as the first argument of your function on the right hand side. And what that means, since in dplyr everything took a data frame as the first argument and everything returned a data frame, that means you can just pass data frames through functions using pipes. So here we're going to do exactly the same thing we did earlier, but with pipes instead of using data 2, data 3, data 4. Okay, let me run the whole thing for you and just convince you that that's true, hopefully. So, same answer that we got there, right? What it's doing is it's taking the data, it's mutating it. Let's just run those first two. Right, let's change the spend amount. The next thing, that is getting piped into here. So it's getting grouped by gender. Oh. Yep, missed out a bracket there. And so as I said before, it looks the same, but now it's got this group on it. And then that gets piped into summarize, which gives you your answer. Okay, we're going to look at another example. Right, so, different question. Is the spend amount different for different age groups? Okay, so obviously quite similar to what we just did up there, but with age group instead of gender. And actually, yeah, I think we're going to look at both age group and gender at the same time, which is really easy to do in dplyr as well. So you notice that there were some people who've got gender unknown. Let's just filter them out. Let's just get rid of them. I want to drop all the observations where we don't know the gender. I want to drop all observations where we don't know the age group. So I'm going to run through this step by step. You start off with the data. Okay, at no point have we ever changed what data is. So it's exactly the same as it was at the start. Going to run it through a filter, which takes out all unknown genders, and we're going to run that through a filter, which takes out all unknown age groups. Let's have a look at it. Right, so actually still looks the same. There's not a lot of unknown gender and age groups. There's less data now though. See here, 13,000 instead of 14,000. Okay. Okay, same thing as before. We're going to run this through mutate, change the spend amount. So if you just run those first two lines, yep. And now we're going to take this data frame and we're going to run it through group by, or we're going to run it through summarize. Okay, so one thing to notice, here I've grouped by age group and gender. Have a think about what you think is going to happen when you group by two variables. Okay, so we've got all possible combinations of age group and gender, and we've got our summaries calculated for each of those groups. Interesting. Okay, two things to notice here. First of all, notice we've still got this thing, it says age group, which is a bit annoying. Right, I would, as a rule, make sure you always remove any extra groupings that you might have lying around, because it can cause some funny results. So when you group by two variables, dplyr will only remove the grouping from one of the variables when you use summarize. So you need to run ungroup afterwards, which will remove the second grouping. Let's run that and I'll show you. Right, you see the grouping's gone. Because otherwise, if you have groupings, things might not do what you expect them to do. Okay, now, it's also, I find this a little bit hard to read, so let's arrange it by gender and by age group. So that's, again, remember back to the verbs at the start, we're just ordering this. And you can easily order it by two variables. Gender first, and within gender it's sorted by age group. Okay, interesting. Yep, looks like the spend amount. Looks to me like the spend amount is pretty even across all sorts of genders and age groups. Maybe it's a little bit lower for males 40 to 49 and for males 13 to 17. I don't know. Median's the same everywhere. Okay. Right. Here's the next question we want to answer with dplyr. I'm just going to see another example of how to chain together all those verbs to answer questions. This is a bit of a trickier one, so hopefully you've been following so far. Does the amount of spend increase with increasing spend number? So people are playing the game, they might only spend once, so they've got one spend number 1. They might spend 3 times, they've got spend number 1, spend number 2, spend number 3. We want to know if people are paying more on those later spends, or if it's pretty steady the whole way through, or if the later spends are spending less. Okay, so let's before we run anything, let's just try and go through what's happening here. We've got data which we're grouping by the user ID. So now all the same people are going to be in the same group. Okay, so within those user IDs, we're going to arrange by time. So now we've got a data frame, lots of groups. Within each group, it's ordered by time. Okay, makes sense. So this is, now we've got people and their spends in order. We can use the row number function, which will give you the row number. And since we're using it after group by, we haven't ungrouped within the group. And then we're going to ungroup. So let's just run all that. Let's see what happens there. Okay, that again. I'm going to change the window size and run it again so you can see it because it's a bit small. Okay. Oh. Okay, so we've got this user ID here. I'm going to highlight all the ones with the same user ID. Okay, same user ID, so they're obviously she's staying the same gender and staying in the same age group. And we've got the amount she spent each time. And we've got the number of the spend. And then we get a new user ID. There they are. Yep. And we see each of their spends. And they are happening in time order. Okay. So that's where we are up to here. Now, remember we're interested in if the average spend at spend number 1 is greater than the average spend at spend number 2, etc. So let's group by spend number now. And let's just use summarize again, and let's find the mean and the median spend number. We'll also find how many people got to each spend number. It just gives us an idea of how accurate our estimates are. Right, okay, interesting. So, at spend number 1, do you have a look at this? Do you see any change? Spend number 10 looks like it's a very high spend, but then only 67 people ever get to spend number 10. Spend number 14 is quite low, but only one person spent 14 times. So that's quite interesting. So you know first of all that no one spent more than 14 times. It also seems, eyeballing it anyway, that people aren't spending any more on their later spends, but they're not spending any less either. So quite a complicated question. I think to be answered quite relatively easier with dplyr. So remember the 5 verbs and the grouping and group by, and if you've got data, go through it step by step, check what is happening with each step. But yeah, should give it a go with your own data. Let us know how you get on. You can look at the tutorials on our website for more information about connecting to direct access, because I did do quite a quick introduction to that. Yes, and good luck with R.